in this lesson, we're going to be taking a look at graphing equations and describing their transformations that involve negatives, specifically multiplying by a negative such as what you see right here. We got the negative out front, so not subtracting, but rather making it negative, multiplying by -1, if you will. So in this lesson, since we're taking a look at these negatives here, we need to figure out what that does to our graph. And because this is the first one we're going to be graphing with such a negative in there, I'm going to go ahead and make a table so we can see what that looks like. And so I'm just going to go ahead and grab a bunch of x values. Now, the x values we use when making a table, there's nothing special about them. We're just grabbing some so that we have something to pull from. I'm just going to grab the numbers from -5 to 5. Nothing magical about choosing those in particular. So now I'm going to figure out what the y value is that goes with each of those. Well, let's go ahead and do the -5 first. So in order to figure that out, I'm going to have to do -5. I'm going to put in parentheses, so that's what I plugged in. +3, and the absolute value, then +5. All right. Now we got to do order of operations here. Now order of operations tells us to do the stuff inside the parentheses first. The absolute value bars act as parentheses here. So that negative is still out front there. But then we're going to do -5 plus 3, which is -2. Now I need to do the absolute value. So the negative is still hanging out front. Notice, because it's outside of the absolute value, it doesn't get affected by the absolute value here. So then, the negative that's on the inside, though, that one does get affected. The absolute value of -2 is a +2. So that's going to become just a 2 here. And then we still have the +5. Then I'm going to do -2 plus 5, which is 3. So that means that -5 for my x value becomes 3 as the y value. So that gives me a point. And then I'm going to do the exact same thing for all of the other y values. Let's get those values real quick. These are what all those y values would be. Now, if I want to see what the graph looks like, it's just a matter of plotting those points. So for instance, -5, 3 would be left 5 and, nope, that's a +3. So that'd be left 5 and up 3. So that is -5, 3. I'd plot that point right there and then repeat the process for all of the other ones. And when I do that, those are the points. Now this actually gives me a picture of what this graph is going to look like. I can see that it's going to be the V-shaped graph, which is what we're used to seeing with absolute value. And it does look like it's just totally straight and it's got its vertex there. In fact, I'm even going to draw in the lines there so we can see that graph as it is. Now notice where my first point was. My first point ended up here at -3, 5. Well, that tells me that that's the exact same thing that these would have done normally. The negative did not change whether we are going up, down, left, or right. The negative didn't impact all that. I still started by going left 3 and up 5. The only difference was that instead of opening up from there, I opened down. If I was going to describe these as transformations, I would describe that as a reflection across the x-axis. If you prefer, you could also say flip upside down. But we do need to say which way it's being reflected or flipped. Sometimes I'll see people just say, oh, well, it's just reflected or it's just flipped. But there's so many different ways that you can flip something that we need to be specific about which direction it is. Based on this problem now, we can see that all the negative does is flip our graph upside down. It doesn't change the shape of the graph, and it doesn't change where we start our graph. It only changes where we go from that first point. So with that in mind, we can go ahead and continue on and look at all the rest of the different types of equations that we might see that use this. All right, next one. Let's take a look at a quadratic. As we're doing these, of course, make sure you are writing this stuff down as we go. So, first thing I'm going to do here is I'm actually going to list out the transformations. Now that I've kind of seen how the transformations work, I want to list those out. So, the shifts. Let's start with the shifts. The -6. Which way does the -6 move it? Well, it's inside with x, therefore it moves it in the x direction. Minus in the x direction, remember, moves to the right. Kind of backwards from the way you would think it would be. The +9 hanging on the end. That one does move up or down. This one happens like you think it should. So plus does indeed go up. So we know it's going to be shifted right 6 and shifted up 9. But what about the negative out front? We can't forget about that. That is going to be flipping it upside down, or in math, that is a reflection across the x-axis. Now, sometimes you might just be asked what the transformations are, and so that's what you would put down. But in this case, we're actually going ahead and graphing it in this problem, so let's go ahead and finish it out and actually make the graph for this. The first thing I'm going to do is plot my first point, which is going to be right 6 and up 9. So I put my first point over at 6, 9. And then I'm going to make my usual quadratic graph. But normally my quadratic graph would go like this. It'd open upward from there. This is going to be the exact same graph, except it's going to be opening downward instead. But all of the numbers are going to be the same. So for instance, whereas I would have gone over 1, up 1, in this case, I'm going to go over 1, down 1. And that would bring me to these points here. Or after that, I might go over 2 and down 4. And over 2 and down 4, you can see are right there. So the only difference is that instead of going up from that first point, I go down from that first point. But of course, the first point doesn't change because of the negative. All right. So that means then that this graph is done. Do have it in your notes so you have it to look back on. Next problem. This time a square root. Okay, so for this one, we need to graph our square root. The first thing I want to do, though, is think about the transformations. So let's go ahead and list out the transformations first. Before I do them, go ahead and see, can you write out what each of the transformations are for this one? Hopefully you are coming up with right 1, down 3, and reflected across the x-axis. Now, I'm going to go ahead and make a graph for that. So since it shifted right 1 and down 3, the first thing I'm going to do is put a point right 1 and down 3. Then, this is a square root graph, which normally would look like this. However, because it is negative, instead of going up and to the right, it's going to be going down and to the right. Notice, it did not change the left-right part. Sometimes when we get to square root, I'll see people want to go to the left, but no. It only flips it upside down. So that means it still has to point to the right. It just goes down and to the right instead. And of course, it does follow all the same steps along the way. So from that first point, I go right 1, down 1. Then I go right 4, down 2. Then I go right 9, down 3. And then I have my graph. Next problem. Here we have y equals negative x plus 4. So for this one, again, the first thing I'm going to do is list out the transformations. So for those transformations, I have just a negative in front of the x, and I have the plus 4. Well, the plus 4 is going to be my only shift then. The question is, which way is it going? Well, notice there's no parentheses around it. If I did this, then it would be moving it left or right, specifically left in that kind of a case. But we don't have those parentheses. Because we don't have those parentheses, that means that plus 4 is outside the parentheses, just hanging on the end. That means it's moving it up or down. So the plus 4 is going to shift the graph up 4. And of course, the negative reflects it across the x-axis. So if I'm going to make this graph then, I start with my shift, which means I put a point up 4. Then my normal graph, if it was just positive x plus 4, would be going up 1 over 1. Well, this one's not going to be going up 1 and over 1. Remember, the negative means that our ups become down. So instead of up 1 over 1, it's going to be down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, all the way down. Of course, I can follow that same pattern going on the other side as well. Draw in the line that goes through those, because of course this is a line. There's no squared in it. There's no absolute value. There's no square root. There's nothing different about the equation that changes the shape, so it's just a line. And so that would be your final graph. Having done these, you should now be able to graph any of these types of equations that you might see that involve the reflections.